Hello, and in this video we're going to look at the central difference approximation in section 1.5. The textbook gives the definition of the central difference approximation as f prime of a is approximately f of a plus h minus f of a minus h over 2h. In reality, that's just the slope of the tangent line, which is f prime of a at point A, is approximately the slope of the secant line on 2 points close to A that are just h distance apart. All right, so we're going to take a look at this in Desmos and go through an example. So I've put in a graph in Desmos here. We're going to look at a single point here. We're going to approximate at the point 2. So first of all, I typed in the function I have as graphed. I put in f of 2 to figure out the point I wanted. I'm going to put this point in there on the graph, and I'm going to label it so you can see it here labeled on the graph. We're going to do an approximation of the slope at that tangent line. Now to do that, I've decided we're going to use the a value of 0.1. So first of all, I plug in 2 plus 0.1 into the function to figure out its point. Its y value. Then I put in 2 minus 0.1 to find its y value. And then I plug into the formula what is the approximation of f prime of a. So I'm using these 2 points. I'm using f of 2 plus 0.1 minus f of 2 minus 0.1. And then the a value, again, is 2 times 0.1. So I get an approximate slope of negative 3.99. Now, I think the slope there is actually negative 4, but let's take a look at the 2 points. I've labeled them, and we're going to zoom in on this section to see those 2 points. So here are the 2 points, and let's see, I've labeled, and I've got, we also want to show the points. There it is. So there's the secant line. I think the tangent line is this line here, and we'll take a look at how close that is to the secant line in a minute. Let's zoom in a little bit more. So you can see here that the dotted purple line is a little bit different than the tangent line slope. All right, they're separating out, but they're pretty close to one another. It's an approximation. We approximate the slope by negative 3.99, whereas the slope is actually negative 4 at that point. Now, we can do this on the Desmos, but we can also do this if you just have a table of values. So if you have a table of values, if we're looking at a table of values, and we want to find an approximation for the derivative or slope at the point. Now, I've done a second example here that lists time and temperature. So it's increasing over time. So time at 0 value, it's 68 degrees. 1 at 70, 2 at 74, 4 it's 86, and 6 it's 100. So if I wanted to find the approximation at t at 1, since I don't know exactly what's happening there, I would use the closest two that are the same amount apart from 1. So there's a point that's 1 away that's lower and 1 away that's above. So I'd use those 2 points and I would calculate that out. And so I would say the approximation of the derivative at 1 would be 3. That means the slope of the tangent line is approximately 3 there. We can also use this to approximate values. Okay, so we could also do this at a value that's between two values. So let's say we were going to do approximately 5. 5 is halfway between 4 and 6. We can do that by using the values for 4 and 6. T prime at 5 would be approximately 100 minus 86 divided by 6 minus 4. And that would be an approximation of the value at time 5 for the derivative of the slope at that point.